Hey, what up guys, Ashton here from MyCanMed, and here we're going to go through the sets question type. Okay, this is part of abstract reasoning, and in fact it is over 90% of the questions will be the sets question type. Okay, that's roughly 50 out of the 55 questions have been a sets questions in previous UCAT. Okay, so it's a huge chunk of abstract reasoning. And how are we meant to do these questions? Well, first of all, you're given two sets, set A and set B. And we're trying to figure out the pattern for set A and set B. So in the case on the left here for set A, there is some sort of pattern there. And in set B, there is some sort of pattern here. Now, the pattern is within each of these 6 squares. So you're always given 6 squares for set A and set B. And you always find the pattern within each 6 squares. So each square is actually independent from one another. Okay, but the pattern exists inside the square that makes all of these squares in common. Okay, please do not link your squares together. Say, oh, maybe your pattern is going from here to here to here to here. It doesn't actually matter. Okay, like I said before, each square is independent. So if I were to cut out these 6 squares and jumble them up in any order and put them in a row, the pattern will still exist because the pattern is inside the squares and not linking in between different squares. Okay, so if I take a look at set A and set B, how do I go about finding my pattern? And what type of patterns does UCAT use? Now we've come up with a checklist that actually helps you to find the patterns for UCAT. And in fact, any pattern in these sets question can be mapped onto one of these 3 types of pattern: a position pattern, a matching pattern, and a counting pattern. Okay, and what is all the dotted points? Now the dotted points are the features that you check which can make the position pattern. Okay, now for example, the first one says position. That position pattern has features in the same position, and your features are shape, color, and rotation. Okay, so if we take a look at our first question, okay, well, our first set, this is actually a position pattern. Okay, so this is a position pattern, and what is the pattern? Well, as I said before, you check to see if there's a shape, color, or a rotation in the same position for all of my squares in set A and for all of my squares in set B. And you do notice one thing. Okay, so here, I can see that there's always a circle in the top left, and that essentially is a position and shape pattern. Okay, so a position pattern and the feature is the shape. So a circle in the top left of the square every time. Okay, so for set A, the pattern is circle in the top left every time. Now you have to realize, if you find a pattern for set A, to see if it is a valid pattern, you have to check to see if it exists in set B. Okay, and we can see that actually, yes, set A does not have a circle in the top left. Okay, so it's pretty good to say that, that would be the pattern to distinguish whether or not a square belongs in set A, that there is a circle in the top left. Now for set B, it's very similar, because if you have a position pattern for set A, it will be a position pattern for set B. Okay, now you take a look here and you see, yes, there is a circle in the bottom right each time. Okay, there's a circle in the bottom right each time, so hence that is your actual pattern for set B. Okay, so remember, your pattern for set A and pattern for set B has to be different, otherwise you can't distinguish which square belongs to which set. Okay, so your rules for set A and set B will always be different. Okay, now what's happening with all the other shapes? Now all the other shapes, like these ones here, okay, the ones that, everything that I didn't highlight, are actually called distractors. And this is one of the difficult things in sets question types. There are a lot of distractors that help me find this type of pattern. Okay, so it's not just for this type of pattern, position. So in all the other patterns that we'll see later, there are lots of distractors. So yeah, that's the thing that complicates the situation. So how do we know whether something's a distractor or not? Well, you take your checklist and you work through your checklist once, okay, and then you'll find all your patterns. And after you found all the patterns, then anything remaining is just your distractor. Okay, so this here, that's the position pattern type. Okay, it's the same color, shape, or rotation in a position within the square. Okay, now the next type of pattern we can see down below, we call a matching pattern. Okay, so this one's a matching pattern. Okay, that's for set A and set B that we have here. Okay, now what is a matching pattern? So if you take a look at the checklist, number 2, it says a matching pattern matches two features with rules. Okay, so it's going to match A and B with some sort of rule. Okay, now how can they match? Well, they can match shape, color, rotation, or position. Okay, so shape, color, rotation, or position. So here we can see that we do have shapes. Okay, circle, triangle. Okay, we do have arrows. Okay, the arrows either pointing to the right or to the left, so that's rotation. Okay, and we don't really have color. Well, the arrows are always black in color and the rest are always white, but no pattern there. And position. So with this type of rule, I'm going to match probably my arrow with a shape. Okay, so the rotation of the arrow with one of the shapes. So if I take a look at my arrows and I see, well, this arrow is facing to the left, this one's to the left, this one's to the left. Is there anything in common? Yes. Every time the arrow points to the left, there is a square. So that is my rule for A. Okay, so my matching rule, if there's a square, the arrow will point to the left. Okay, now what about all the times the arrow is pointing to the right? Okay, when the arrow is pointing to the right, we can see that there's always going to be a circle. There we go. So that must mean that the triangle is a distractor. Now if I take a look at B, I know because it's a matching pattern for set A, there has to be a matching pattern in set B. Okay, you won't get a matching with position pattern. So what I mean by that, sorry, is you don't get a matching pattern in set A with a position pattern in set B. That just doesn't happen. Okay, but you can get a matching and position pattern. Okay, so one of the features may be position. So for example, if you could have, if there's a square in the top left, the arrow will point to the left. If there's a square in the top right, the arrow will point to the right. Okay, so matching with position does actually work. But anyway, this is not the case. This is just matching a shape with the rotation. So B has to have a different rule compared to A. Okay, so if I look at all my right arrows, what do they have in common? Okay, they have a square in common. Okay, so that's with my right arrows. Okay, so my right arrows will have a square. So a square will point to the right. And we can see that that is a different rule compared to set A, so which is all right. Okay, because remember, you can't have the same rule for set A and set B. Okay, now for the second one, if the arrow is pointing to the left, we can see that there is always a circle. Okay, so if the arrow is pointing to the left, there's always a circle, which again is a different rule from set A. In fact, they're the opposite rules. They don't have to be opposite each time. Okay, like for example, instead of having a circle, you might have a triangle, means the arrow is pointing to the left for set B. Okay, but we can see that you just have to check that they are different. Okay, so that is the matching pattern. You're matching a shape with a rotation or other things. Okay, so you could get shape with color, color with rotation, or rotation with position. Okay, that is your matching patterns. Now onto the last type of patterns is the counting patterns. Okay, now with the counting patterns, you just count the features. And you usually count less than 10 because if you're counting more than 10 within each squares, then you're not going to be able to finish the question on time. So UCAT likes to keep the count less than 10. Now what are things you can count? You can count shape, color, edges, intersections, corners, and spaces. Okay, so these are the features that you can count. Now if it's not a counting pattern, but it still looks like counting is involved, it will be a matching and counting. So you're counting using a special rule. Okay, so matching and counting, you're still counting these things, but just counting them in a special way somehow. That actually forms a pattern. Okay, we'll have examples of this in the next one. Here you go. Okay, so a regular counting one is pretty simple. So there's no distractions here, so it makes it even more easy. Okay, usually you do get distractions, but for the sake of showing you just what a counting one is, you can see here on the left there's always 1 or 3 circles. And remember, for B, there is 2 or 4 circles, and that is your counting pattern. Okay, so for A, it's 1 or 3 circles, and for B, it's 2 or 4 circles. Okay, it will belong to B, and you have lots of other distractors to try and distract you. But yeah, that's essentially what a counting pattern is. Now remember, it's not just shape that you can count, but colors, edges, intersections, corners, spaces. Okay, lots of anything you can count may form a pattern. Okay, now one thing to take note of is sometimes UCAT doesn't just say this is strictly 1 and 3, but they like to use odd and evens. Okay, so that's another way to represent this information, odd and evens, particularly if you have like one square which has like 6 circles, then it will definitely be odd and even. Okay, now what do we have going down here? So again, no distractors to help highlight my point. But here we have, circle and triangles. Now you might want to count the number of edges, okay, but to simplify things, we usually work through our checklist in order. Okay, so it should be a counting. Let's check counting with shape first. And in fact, this one is a counting with shape. Okay, you just count the number of shapes. But hang on, you've got 1 circle here, 3 circles here, 2 circles here, 5 circles here. It's always changing. But it can be a matching and counting. Okay, so you're just counting using some sort of special rule. And in this case here, we can see that there are triangles and there are squares. So when there's a triangle, there's a special way you count things. And if you take a look at all the triangles, how many circles are in each of them? It's actually an odd number of circles whenever you have a triangle. Okay, so for set A, our first rule is that you count whenever there's a triangle, there will be an odd number of circles. Okay, so odd number of circles whenever there's a triangle. And for the other one, a square, you can see every time there's an even number of triangles. Okay, whenever there's a square, even number of circles. And there's your matching and counting rule. Okay, odd and even within set A, depending on whether you have a triangle or a square. And that's one type of matching and counting pattern. Okay, now for B, if it's a matching and counting pattern in set A, it'll be a matching and counting pattern in set B. So here we only have triangles and trapeziums. Okay, you can't have the same pattern in set A as with set B. So most likely set A was odd circles, so set B should be even circles, in which case it is. Okay, so there's an even number of circles for set B. And what about the trapezium? Well, for the trapezium, it is an odd number of circles. Okay, so there we go. That is all our patterns, and that's how we go about trying to find them. So you have this checklist, and literally all the patterns in the UCAT will be one of these 3 patterns. Sometimes you might get multiple patterns within the same 2 sets. Okay, so you might get a position pattern, and you may also get a counting pattern. Okay, so how you're supposed to find all the patterns is to just work through this checklist, okay, in order to find the corresponding pattern that is inside your sets. And once you work through this checklist and you've finished it, anything left over should be a distraction. Okay, so you just work through this checklist once and find all your patterns. Now at the beginning, you probably won't find a lot of patterns. You'll be missing a lot of the patterns. So let's say this one was a matching and counting one. Okay, so since you missed this matching and counting one, and you worked through your list but you still couldn't find it, what are you supposed to do? It means you're supposed to go back to your list and try and refine your list to be like, hang on, I missed this matching and counting pattern. So in the future, how can I check similar patterns to make sure I don't miss out on this matching and counting pattern here? Okay, so you can slowly refine your list by by going through questions and seeing the patterns that you don't find, okay, and then reflecting on it and then making your checklist better by refining what exactly you're meant to look for let's say matching in shape or matching in color, okay, and then through practice you should get better and better at checking and using your list. Okay, now it should be at one point in time when you've actually refined your list to a point where actually you can find all the patterns pretty easily. Okay, but at the beginning you'll struggle, but remember, just come back to the list and realize, oh, what type of pattern was that? Why did I miss that pattern? And slightly put notes into your checklist to make sure you don't miss out that pattern in the future. Okay, and then eventually you will cover all the patterns in UCAT and you'll find it pretty straightforward. Okay, so that's it for section 4. Now, here is a question. Try and find the pattern for this question here. What type of pattern is it? Position, counting, matching. Okay, and then I'll just give you some time, so please pause the video, okay, and try and find the pattern here. Okay, now that you've found the pattern, okay, we have questions associated below. Okay, so there's 5 questions. Okay, so there's always going to be 5 questions attached to one premise for sets question type. Okay, so again, just pause the video and see if you can actually determine, the answers to these questions. Which of the following belongs to set B, set A, set A. It's a pretty straightforward question. Nothing out of the ordinary. Okay, and here are the last 2 questions. Okay, so make sure you just press pause. Okay, and try and find the answer. Okay, now that you found the answer, let's go about how to actually use our checklist in order to get the answers here. Now, what I said before, here's your checklist. You're meant to work through your checklist once in order to find the answer. Okay, so is there a position pattern going on? Is there a shape in the same position each time? There's definitely a shape in the same position each time, because you have 9 arrows and they're all in the same position. However, they all have different orientations, so it's not like there's a particular arrow in the same place each time. Okay, it just doesn't happen. Not like with the previous one. With the previous one you had a circle in the top left, circle in the bottom right. That was your position pattern. Here, yes, you do have 9 arrows, but nothing in the same position. Okay, it's the same with position and color. The colors are not in the same position. Okay, they're everywhere. Okay, and rotation as well. Yeah, so the arrows are not rotating in the same direction. Okay, so you don't in a particular position. So you don't have a position pattern. And in fact, looking at that, you can probably tell that almost straight away. Now, a matching pattern. Is that some sort of thing that matches 2 features together? Okay, so matches 2 features with rules. Now, indeed, there is a matching pattern here. If I take a look at shape first, there's nothing to really match because everything is an arrow, so everything is the same shape. So that doesn't help us. But if I look at color, okay, can I match the color with anything? And in fact, I can. Okay, so for both set A and set B, we have a similar first rule. Okay, so what's our first rule? I can see the colors for my arrows, and that is matching with something. And if you just take a look, all the black arrows, something is happening with that color that I can match with something else. In fact, I can match the color of the black arrow, so the black arrows will always point to the left. So it's matching color and rotation. Okay, so the black arrows will always point to the left. Okay, so black arrows left. So matching color with rotation. And as you can see, there is no white arrows, so it works the other way around as well. If it's pointing to the left, you'll get black arrows. And it's the same for set A as with set B. So there's my first rule. Okay, if you have a black arrow, it has to point to the left. Or likewise, if you have an arrow that points to the left, it has to be black. So here we do get the same rule for set A and set B. So that doesn't help me distinguish which one belongs to set A and set B, but we can see it is common in both set A and set B. So if we get an arrow that points to the right that is black, we know that it won't belong to set A or set B. Okay, so that's the main reason why I wrote that down. But it's not enough. Okay, I need to find other rules to help me distinguish set A and set B. So let's take a look. Any other matching rules? And in fact, the answer is no. Okay, so I've already looked at shape, color, rotation, and position. Yeah, nothing to help me there. Now, if I go down to counting patterns, okay, so is there a counting pattern here? Well, there has to be some sort of counting pattern because I don't have a position or matching pattern to help me distinguish set A and set B. Okay, so what can I count? You can count the number of shapes, but everything is 9. Okay, there's always 9 arrows. And if you wanted to, you can put that onto your batch of rules as well. When you're counting, there always has to be 9 arrows, but it's really obvious, so I won't write that down. Okay, can I count the colors? So if you count the colors individually, there's always going to be 3 or 2 black arrows, and it's the same for set A as in set B, so it doesn't seem like it's going to be a pattern. Now, is it 3 or is it 2? It doesn't matter. It's not going to be the pattern. You won't count edges because there's way too many edges. We're way above 10. There are no intersections. Corners again will be way above 10. Spaces will be the same. There'll always be 8 spaces or 9 spaces. So enclosed spaces are just counting the areas that are enclosed, by lines. And it's obviously not going to be an enclosed area counting pattern because it's always going to be the same for set A and set B. Okay, so you're only left with matching and counting. And in fact, when you're looking at this, you're probably thinking, yes, it's going to be matching and counting. You're going to count something with some sort of special rule. Okay, and that rule will give you what the pattern is. Okay, so where do I start counting? Now for matching and counting, or for all patterns in general, you always try and look out for the square which you think will help you the most. Okay, the squares that will help you the most are the squares that have the least different features. And so for set A, I would look at the top right. Okay, definitely the top right square. Now why do I focus on the top right square? Because the arrows are only facing either up, down, or left. There's no right arrow. See, this one has up, down, right. Okay, this one has up, down. See, all of them. Oh, this one doesn't, so I could have focused on this one as well. Okay, this one has up, down, right. This one has up, down, right, and left, of course, because it's black. Okay, so because these squares have like 4 different directions, whereas these squares only have 3 different directions, you have eliminated like one of the distractors to help you find what the pattern is, and it's much easier to find the pattern with less distractors. Okay, so you always look at the squares with the least amount of potential distractors. Okay, so if I take a look at this one here, okay, it has going up 4 arrows, going down 2 arrows, and going left 3 arrows. Okay, so that sort of makes a pattern straight away. Okay, so the up arrow, okay, that's 4. The left arrow, which is black, okay, there's 3. And then the down arrow, there's 2. And so maybe the pattern is, okay, the number of black arrows, okay, let's call that X. If that's 3, then the number of up arrows will be X plus 1, and the number of down arrows will be X minus 1. Okay, so that's one of the possible rules. And if you check with, let's say this pattern here, why? Because it's got no right arrows. You can see that it is indeed correct. There's 4 up arrows, 3 black, 2 white, which follows exactly the same as this one here, which is fantastic. Okay, now this one, would it be the same? 1, 2, 3, yes. 4 up, 2 down, that's correct. Okay, so this pattern does hold, but these ones only have 2 black arrows. So what's happening here? 2 black arrows, and then up arrow is 1, 2, 3, which is indeed X plus 1. And down arrow is just one of them, which is X. Okay, so the right arrows is actually your distractors. Okay, so those are your distractors that you shouldn't look upon. Okay, now it's the same with, this one's the last one I haven't checked. 2 left arrows, so that means I should get 3 going up, 1, 2, 3, and 1 going down, which is correct. Okay, so that's a pretty solid pattern. It works for everything in set A. Now for set B, it can't be the same pattern. Okay, so if I take a look at set B, I've got 3 to the left here. Okay, so again, fill up my arrows. Okay, so that's 3 to the left. And what about the other ones? Well, there's one going up. Oh wait, I should focus on the one which has the least different directions. Yeah, which is that one, because it only has up or down for the white arrows. Okay, so for the up arrows, you can see that there's 2 that's going up. Okay, so the up arrows has 2 that's going up, and the down arrows should have 4. 1, 2, 3, 4, which is indeed the case. So here, if I call the black arrow x, the up arrow will be x minus 1, and the bottom arrow will be x plus 1. This is viable because, these are different from the rules in set A. Okay, so it makes sense. So if I take a look at this one here. Okay, so on this one here, left arrows, that means the up arrow, there should only be 1 of them because there's 2 black arrows. And then the down arrows, you should have 3 of them. 1, 2, 3. Okay, so that is correct. Okay, so it will be 1, 2, and 3. Okay, likewise for this one here, there's 2 black arrows, so therefore I should get 1 arrow going up and 3 arrows going down, which is correct. Now this has 3, so I should follow this number exactly. Okay, so it will be 4 arrows going down, that's correct, and 2 arrows going up. Okay, and you can see that this is indeed your rule with your other squares. Okay, so this is a matching and counting. You're still counting, but you're counting with a special rule. And these are your special rules. Number of black arrows there are. Okay, it means that for set A, there would be number of black arrows plus 1. Okay, and for the down arrow, there'll be the number of black arrows minus 1. And then for set B, okay, you count the number of black arrows. Okay, then the pattern is for the up arrows, it's the number of black arrows minus 1, and for the down arrows, it's the number of black arrows plus 1. Okay, now with all the patterns that we have now, that can be used to find all the patterns in question number 1, 2, 3, 4, 5 that we have down here. Okay, so which of the following test shape belongs to set B? So it follows this rule. Okay, there's 3 black arrows, so that means it follows this one exactly. 2 going up, 4 going down. Okay, so for set A, 2 going up, 4 going down. Yeah, so that is indeed our answer. Our answer is A. So straight away, that is correct. Okay, so the rest is definitely wrong. Okay, so here we can see there's 2 left arrows, so that means there should be 1 up arrow, but there's not. That's more than 1. And here it's not even facing to the left. Here it's not facing to the left. So it's definitely not B, C, or D. Okay, now for the next one, for A, it says which of the following belongs to set A now? Set A is our first set of rules for set A. Okay, so here we've got 2 left arrows, so that means the number of up arrows should be 3. 1, 2, 3, that's correct. Number of down arrows should be 1, which is correct. So A should be our answer there. Okay, so checking B. B is not an answer because the black arrows are facing to the right. C, okay, checking that that's not our answer. There's 2 black arrows. Okay, so that means you should get 3 arrows that face up. 1, 2, 3. Yep, that's correct. And 2 arrows that face down. 1, 2. No, there's no 2 arrows that face down, so C is not our answer. Also, it's not our answer because that's not black. Okay, now for D. Okay, we have 3 left arrows, so that means you get 4 up arrows, and there's only 3 of them, so that's not our answer as well. Okay, so A is our answer. Okay, now for the next question. Okay, see if you got it correct. Is this correct for set A? 3 left arrows, 4 up arrows, and 2 down arrows. That is correct. Straight away, I got my answer. Now what about B and C? Well, B is definitely possible, 2 left arrows. So that means 3 should go up and 2 should go down, but we don't have 2 going down. That's not our answer. Okay, C, 1 left, so that means 2 up and 0 down. But we got 1 down, or 2 down, so that's not our answer. Okay, here we have 3 down, and there should be 1 down, so that's not our answer. Oh, excuse me. So this is a very quick question to do once you know the pattern. Okay, now for the next one, the only viable answer is C, because it's the only time when the left arrows are black. So that's a really quick and easy one. And for this one here, the only answer again should be B, because these are the only ones that face to the left. And you can double check with the rules and you'll find that they will work. So that's it. And that's how you do these questions. Okay, you just work through your checklist and then find the patterns and then match the patterns with the actual rules that you found or with the pattern that you actually found, and then just answer the questions accordingly. Okay, this question type at the beginning, it might take a long time to find the patterns. Okay, and you won't be able to find a lot of the patterns at the beginning, but make sure you just go back to your checklist and make sure you really map out what type of pattern that is and make sure you find any similar types of patterns in the future. Okay, and then you'll find that, the more you use your checklist, the more you'll realize that, yeah, it's possible to find the pattern, within 1 minute quite easily. Okay, and once you've found the pattern within 1 minute, so that is to use your checklist to check everything, it takes about a minute, and you have another minute to work through and answer the 5 questions that relate to the same pattern. Okay, and that way you can do this question type in under 2 minutes, which is what we're aiming for. But like I said at the beginning, you might not be able to do it in time, you might not be able to find the patterns. So what's more important at the beginning is to make sure you realize, okay, how to check your patterns properly. So if there's any patterns you missed, go back to your checklist and readjust it, refine it so that you're able to find the patterns in the future. And then you reach a point where you'll be finding these patterns in under 1 minute easily. So there we go. If you liked this video and you want more tips, please like us on Facebook and be sure to check out the next video, which will be on section 5.